Hello, and welcome to this video on designing and editing GDS files. In this video, we're going to be having a look at macros and using them to create our own custom PCell. In the previous video, when we had a look at PCells, we looked at the basic library built into KLayout. This included things like circles, ellipses, arcs, and pies, and a few more. The key point of the PCell is parameters. Being able to change those parameters modifies the shape defined by the PCell. For the circle, when we clicked on that, we had these three parameters that we could change: the layer, the radius, and the number of points. When we change the radius, it increases the size of the circle. Importantly, these PCells also had a handle that we could move independent of the shape itself to also change one of those parameters, in this case the radius. Today we're going to be using the macro to define our own PCell. What I want to design is a spiral just like this one on the right here. The first thing we should think about when defining the spiral in the macro is what are the parameters that we're going to want to include in the PCell. The ones that I'm thinking of are the inner radius, the distance from the center of our spiral to where it's going to start; the outer radius, similarly from the center to the outer extent of the spiral; the width of the path itself, the kind of winds of the spiral; and also the distance of the spacing in between those winds. Those four parameters will let us uniquely define a spiral. We could choose a different combination, maybe something like the number of turns instead, but to me this one is more logical for the implementation of our PCell. To actually create a macro for the PCell, we're going to go to the Macros menu and Macro Development. This opens up the Macro Development tab, and I should say that all of these macros are using scripting, and if you don't have any previous experience with scripting, that's okay. We're going to try and go through this on a fairly basic level, so hopefully you can understand what's going on. If you have experience, that's great. There's a few extra things you need to learn to use them in KLayout, but that should be pretty easy to pick up. And if you want to learn more, you can look at the KLayout documentation or general Python documentation to learn more. I'm going to be using Python for all of my scripting. That's what I'm more familiar with. You could also potentially use Ruby if you like. The first step is going to be to go ahead and create a new macro. So I'll click New here, and it gives you a few options. I'm going to select one of the samples here, which is a PCell sample. Let's click OK. It's going to create it over here, and we'll name it Spiral. All right, so on the right here is the actual meat of the PCell. We're going to be changing a lot of things here, so we'll kind of go through it step by step to see what's going on. Throughout, in this particular example, there's a bunch of comments in gray here. They're either contained within triple quotes or with a line prefaced by a £. Those help you kind of understand what the different parts of the file are doing, so hopefully that can guide you to make changes above and beyond what we do here. The first thing we want to do is change the class in this file. The class is actually what's going to contain our PCell. So in the original sample file that we're looking at, it's defining a circle, that same circle that we looked at just a second ago. We're going to be changing it to be a spiral, so we're going to change things like all these references to circle. We now want it to reference our spiral that we're making. Just changing the name of it over here. The first function inside this class is the init, or the initialization class. All that's contained within this class is setting up the various parameters of our PCell. So you can see in the circle implementation, they're setting up the layer, this S parameter, which we'll talk about in a moment, the radius, and the number of points. Those are the parameters that we saw when we looked in the menu. The S, as you look here, is a type shape that actually corresponds to that handle, that dot that we can move around to change the radius of the circle independent of this radius parameter in the actual PCell menu. So we're going to want to include that in our spiral implementation, but we're going to want to change it around a bit. So let's start setting up our parameters. I'm going to move this one up here just to organize things. The order here really doesn't matter, it just seems more logical to me this way. So we have our layer and number of points, that's going to be the same. The next thing we're going to want is our inner radius. Let's move that up here. And then I'm going to name it inner R, and we'll put the display text as inner radius. So, and the default value to 1. So yeah, to go through this again, we're setting up the variable name first. So that's what whenever we want to reference this variable within the context of the script, we're going to use this first name here, in this case inner and outer radius. The next is the type. In this case, these are both type double. That refers to a double type of number, which is like a floating point number in Python, a double precision number. And we want floating point numbers so that people can enter values that are not necessarily integers, but have a decimal place after them. And the last value is the default value. That's what the PCell will use if the person doesn't give it any initial starting parameters. This is the default values that it'll set up. So I'm setting the inner one to 1 and the outer to 10, so they're quite large and different. Good, so those are our radiuses. The next parameters we talked about were the width and the spacing. So let's go ahead and get those done. So again, I'm going to name the variable as width so we can remember what it is throughout here. You're, of course, allowed to name variables anything you like within reason. It just finds it a lot easier to keep track of things if you name them logical, reasonable things. I hope I am doing that here. So this next one is going to be the spacing. Again, it's a double. Again, we'll change the display text. That's what the person is going to see in the menu. Spacing and a default of 1. Good, so we've set up all the floating point parameters that we're going to need for our menu. The next thing we want to worry about is those handles that I talked about earlier. So we have this S variable. I'm going to call this inner handle. This is the dot that we can move around that's for the inner radius of our spiral. Again, it's a type shape, and the default value here, it doesn't have any display text. The default value is a point. So that's literally a point that's going to be drawn on the layout. That's going to be the dot that we can move around. We're not going to worry too much about the coordinate of the dot for now. We'll worry about it a little later on in the file. So I've also created another one for the outer handle. That's looking good. Next, we have some hidden parameters here. So it says these are used to determine whether the radius has changed or the handle has moved. We're going to talk about that a little more and how we're using that later on, but let's just go ahead and set it up here in kind of the same vein as they did. I'm going to remove this double radius, the diameter. We don't need anything like that here. I'm going to set up this, I'm going to call it, instead of a hidden variable, I'm going to call it a like a memory, a storage value. I'm going to call it mem. And I'll say display text. Not that I think we can see this display text anywhere, but we will set it up anyways. Default value of 0, hidden is true. And let's do the same exact thing for the outer radius. Outer mem, outer mem. Great. So now we have all of our parameters set up in the init function. Again, that's all we're doing in this initialization step, is just setting up our parameters. The next function in this class is going to be the display text implementation. So here, this is the text that's seen when we go ahead and click, or so look at the cell of our pattern. So if I zoom out here, this basic circle, that's the display text. Also, it's the text here in the cell hierarchy. So we want to set up something that kind of makes sense for the spiral. I'm going to name it spiral. I'm not going to bother putting in all the different parameters we set up here. I'm just going to tell it the outer radius. By all means, if more variables would be useful for you, you can set up more of them here. And change the actual display variable to self.outer. Whenever we're referring to any of these variables that we defined here, we preface them with self. Self is kind of the, tells us that it's a variable belonging to this class or the instance of this class, and then the variable name can follow that. Good, so we set up the display text. Next, we're going to the coerce parameters implementation. This is probably the trickiest of these functions to understand. And what it's doing is telling us, is differentiating between when we change the parameter in the actual menu for the PCell. So again, when we pulled up that menu and we saw the layer, the radius, the number of points, whether we're changing those parameters or whether we're moving the handles. Because we only have the handles for the inner and outer radius, those are the only parameters we're worrying about, but we have to kind of distinguish which is changing. Is it the value that's changing or is it the handle that's changing? And how do we update the circle accordingly? So first, we need to define a variable. So I'm going to call this one inner handle radius. It's going to start off as none. And we'll make another one for the outer handle radius. The first thing we're going to check is, does that handle exist? So is it kind of there? Is it a point? If it is, then we're going to compute the distance in microns. So we're going to essentially calculate the radius from the center of the spiral to where this handle is and get a number, that radius number. So when we move the handle, we'll calculate this radius number and feed it back into the parameter for the inner or the outer radius. So we're going to define this inner handle radius as self.innerHandle dot distance. And so it's the distance between wherever this point that we placed is and the point 0, 0 at the center of this spiral. So again, just calculating the radius from the center to this handle point and setting it to this variable inner handle radius. We want to copy this thing exactly for the outer. All I'm doing here is just changing everything from inner to outer because we want the exact same functionality for the outer radius. Handle radius, outer handle dot distance. Great. Everything looks good there. Okay, so now we're extracting this distance for the handle itself, and now we want to say, okay, is it the parameter that's changing, or is it the handle that's changing? And let's update things accordingly. So we're saying we're gonna remove this none part because I don't think it's particularly needed here, and we're saying if the self dot inner radius minus self dot inner mem is less than 1e minus 6, so essentially a very small number. So it's saying, basically, does the inner radius value equal the mem value? So are those two values the same? If that's the case, then it means that someone has moved the handle, not changed the parameter. So if someone's moving the handle, then we want to set both of those parameter values, the memory and the inner radius itself, to that handle radius that we just calculated, so to the actual value based on where the handle was moved. What we're doing here, this is handling, again, the case that the handle was moved, that point was moved, rather than the parameters were updated, and saying once you've moved that, then update the parameters based on that handle position. Otherwise, the other option, if those parameters aren't the same, then that means that someone has changed one of the parameters that the user has in the menu. So in that case, we're going to set inner mem to the inner radius because that's the value that was just changed. And we're going to draw a new point or update the point position, inner handle. And it's now going to be self dot inner radius. It's negative because in this case, we're putting it on the left. That doesn't really matter. It's kind of whatever you prefer, but I think this one makes more sense. Great, so we handle the case where the handle changes and the case where the parameter changes. When the parameter changes, we change the mem value, and we also change the handle position. So now we're just going to take all that, and we're going to, let's copy this part first. And we'll set up the same thing for the outer radius. So in this case, we're saying, has either of the parameters changed? This and that, has this parameter changed or has the outer parameter changed? And if, is either handle moved? And if that's the case, then we want to update those memory values. I'm saying that poorly. If both the parameters for the inner radius and the outer radius haven't changed, if both parameters are the same, then it means one of the two handles has moved. So we need to update these parameters based on the both handle positions. If that makes more sense. Okay, so now that we've got all those updated, we need to handle the outer radius case for the case that we've updated the parameters in the PCell. So outer mem equals outer radius, and the outer handle is getting redrawn based on the outer radius as well. Perfect. That should handle all of that coerce parameter implementation, anything we're changing. We've got an extra line here where they had this double radius before. We don't need that. And the last line here checks the number of points. If the number of points is less than 4, it sets it equal to 4, so we can kind of at least have a square for this spiral. Great, okay, let's move on to the next function. So this next one is can create from shapes implementation. So this is saying when we're creating a PCell, there's a couple different ways we can create it. We can either create an instance of it directly from the instance menu, and in that case it will use all the default parameters, or we could take an already drawn shape and convert it to a PCell. We did that a lot in the other video, converting text to a polygon. When we did convert the text to the text PCell, it converts that text object into an actual physical polygon that would be easier, or actually capable of our lithography tools to draw. So this is checking that when we do that convert to PCell, what kind of shapes are we going to allow to be changed into the spiral? So it wouldn't make a lot of sense, for example, to try and change a box into a text PCell. How would it convert a box into a text? It doesn't make any sense. So it's checking what types of shapes will be allowed for this conversion. In this case, it's saying it'll allow this conversion if the shape is a box, a polygon, or a path. That seems reasonable to me. Same kind of things for the circle. One of those 3 can all be converted into a circle. They should all be able to be converted into a spiral. So I'm not changing that one at all. The next function is getting the parameters from that shape. So when we're doing that convert to PCell, we have this box or shape. How do we pull some relevant parameters to that to use to define the shape of our circle in the past or now a spiral? So what they were doing was they were pulling the radius and saying that it was equal to the shape.boundingbox.width, so the bounding box of the shape that was already there, its width, and setting the radius equal to that times the database unit. So I'm going to set it divided by 4. So I want to kind of take a quarter of that to be the inner radius. And then I'm going to do a similar thing, but with the outer radius. So essentially I'm using the width of the bounding box of that original shape, whatever that was, to define these two radii. So that should be kind of roughly match the same size as that original shape, whatever it was. The layer, I'm not changing that at all. It's just going to get the layer of that old shape and put the spiral in the same layer. That's great the way they were doing that before. The next function is a transformation from the shape implementation. So in addition to extracting those parameters, we probably want to shift where the cell is going to be placed so that it's placed where that old shape was. So if we had a box way over here, and we create this shape without this transformation, this new PCell, it's going to be centered at 0, 0. So we want to offset it, shift it over to be positioned at the center of that old shape. So what it's doing is transforming, that's this trans function here, and it's using the center of the bounding box of the transformation. Again, this is great for what we want to do. I'm not touching that in this case. Okay, great. So this brings us down to the next function, this produce implementation. This is the real meat of our PCell. This is where we're actually going to draw, to set up the spiral and how it's going to appear in our layout. So first, we're setting up some parameters in the actual correct unit. So we're dividing by this database unit. So let's set this up first. So let's have an inner radius in the database units equal to inner radius divided by the database units. And I'm going to set up a second one for outer radius. Perfect, because we'll need both of those. Okay, and then the way that they're drawing the circle is they're setting up an array of points. So we've set up points and it was an empty array, so there's nothing in it. And then it's going to go around the circle and fill that array with all of the individual coordinates that map out that circle. And then we take all those points and we make a polygon with that array of points. We're going to use the same kind of thing here, but we want to set up all those points to kind of follow the path of our spiral, and then we'll convert it into a path. So again, I'm going to define an empty array for the points. They're setting up an angle, a change in angle, like a D angle. So this is how the angle will change as we go around the circle, and they're taking the radians, so 2 pi for a complete rotation of our circle, and dividing it by the number of points in the circle. So in the case, it was 64, so we're dividing that 2 pi into 64 chunks. We want to do the same kind of thing with the spiral. For each rotation of the spiral, we'll divide it up by that number of points. So everything here isn't going to change. I'm going to add a new one for d radius, a change in radius as we go around the circle. So again, for every one of those ticks for the number of points, I want to make the radius slightly larger because I want the spiral to grow bigger and bigger, right? What I want is when the spiral does one rotation, so if we're going from here to here, I want the radius to get bigger by 1 path width and 1 spacing. Right? If I'm going from here, plus 1 path, plus 1 spacing, I'll then be at the center of the next loop when I do 1 rotation. So that means I want to use the self.width plus self.spacing. So that's 1 rotation. I want to divide that by the number of points. So in every little increment, we're getting a little bit larger. And then I'm also going to divide that by the database units, just to get everything in the correct coordinate system, the correct units. Very good. Okay, in this case, they're using a for loop to define the circle. So they're saying as we go from 0 all the way around to 2 pi, or the number of points, this is how we want to define it. I want to use a while loop. I want to say while we're, so let's say we have a current radius, while that current radius is less than the outer radius. So essentially keep going around the circle, keep wrapping on wraps of the spiral until we get to that outer radius, and then you should stop. And that means we want to start this current radius. We're starting at the inner radius, because that's where the spiral is going to start, and it's going to wrap out from there. I'm also going to define a current angle as we're wrapping around rather than using this for loop. And I should define what that angle is equal to. Let's see, set it equal to 0 to start. So just starting at one side of the circle and wrapping around from there. Okay, so while current radius is less than the outer radius, so then I want to append points to this points array. So I'm appending a point and the point that I'm using, so we've got this math here. So this is the x coordinate of the point here, and this is the y coordinate here. So let's set up the x first. So it's going to be just the radius, the current radius, and then times the cosine of the current angle. So essentially we're just doing the trig here to convert these kind of polar coordinates of radius and angle into the Cartesian coordinates of x and y, because we need x and y for all these points we're creating. So current angle, current radius, current angle, and the same thing for y, but for y we're going to use the sine of the angle. Very good. Making sure I haven't lost any parentheses there. Everything looks good. Okay, and then for each pass in this while loop, I want to increase the current radius. So I want it to equal itself plus the change in radius, that little increment as we slowly go out. And I also need to define the current angle equal to itself, oops, spell it correctly, plus the change in angle. And in this case, I'm going to take the modulus of that with math.pi times 2. So 2 modulus 2 pi. So essentially, as the angle keeps going around, we're going to go from 0 to pi to 2 pi. And then we're going to keep going to like 3 pi to 4 pi. And it's just going to keep going up and up and up and up. To me, it'd be a little prettier if once we get from 0 to pi to 2 pi, we kind of go back to 0 and back to like 1/10 of a pi or whatever as we go around. So I'm taking the modulus of it to get rid of that extra, everything above 2 pi every time. This probably isn't necessary, but it seems a little cleaner to me, so I'm just going to go ahead and implement it here. Okay, so we're getting increasing the radius, increasing the angle. Everything's looking pretty good. Then with this loop here, the next thing we're going to do is to actually draw that shape. So we've kept adding these points to the points array. We've built up all these x and y coordinates. Now we want to make a path based on those coordinates. So we're saying in the cell that we're making, we're going to access the shapes of the current layer and we're going to insert, and in the past we were inserting a polygon for the circle. For the spiral, I want to implement a path that uses the points, and for a path we also need to specify the width. And so I'm going to use that width that we defined earlier and again divide it by the database units. Oops. Good, so that will give us the width of the path and all the points for our spiral. That should be good. So now we've completed that kind of the produce implementation, which is actually going to give us the shape, and we're done with that class. The last thing in this file is adding this class to the library. So before we were using the basic library for those basic shapes, we're going to create a my library, a my lib for this new shape that we're creating. So let's go ahead and set that up. We're not going to change a whole lot here. All that's defined is the initialization for this class. We're using the description my first library. That's great. We're going to register. We're going to call it spiral. This is the text that will appear in the menus. And we want to make a call to this spiral class that we just created, an instance of the spiral class. And we're registering it as mylib and then calling an instance of mylib at the bottom. If you wanted to add more of these shapes to your library, if you don't have in addition to spiral, you got I don't know, some sort of array or whatever other cool shapes you can think of, you'll add the classes to the top here. So in addition to spiral, you'd put another one just above mylib here. That's your corkscrew or whatever. And then when you call this here, you're going to register PCell corkscrew underneath this one to add more of these PCells to your library. Okay, so we have everything done in this file. Let's go ahead and save it. And with any luck, let's run it here. No errors, that's a good sign. Let's hop back over to our layout, jump down here. I'm going to instance, I'm going to go to my first library. We've already selected the spiral here. Click OK, click OK. And sure enough, there's our spiral. So when I go ahead and place that, we can close it. And if I Click it, we can see the parameters that we defined. We've got the number of points, 64, our inner and outer radius of 1 and 10, just like we set up with the defaults, and the width and spacing of 1. That's great. Let's see what happens when we change these. Let's change the number of points and apply that. Oh yeah, there we go. We've definitely made it a lot more blocky when we decrease the number of points there. That's good, that seems to be working. Let's change the inner radius, make that bigger. Sure enough, that jumps out. Let's make the outer radius bigger as well. That gets bigger. This is all looking really good. Let's make the width bigger. You can see our path gets larger here. And let's make this spacing bigger as well, much bigger. Oh yeah, and this is all seems to be working great with these PCell parameters. Now let's jump out here and see how the handles work. So again, if I grab these handles and move them, I should be able to change the outer radius of our spiral, which will then change the shape that we're seeing. So if I move this inner one, I'm changing the inner radius, and the outer one changes the outer radius. You might know that notice that it kind of jumps around a little more. Whoops. When I change the inner radius, and that's because we're always starting it at 0 angle on the left here. So because of that, I mean, the shape might shift a little bit left and right because it's always starting in the same point. Whereas it will just add on to the outside when we change the outer radius. You could potentially change this so that it catches the angle from these handles as well, but I'm not going to do that in this particular implementation. For me, this is good enough, and I can rotate it if I want to above and beyond just using the geometry part of this. So I can rotate it by 90 degrees here and apply, and it's now rotated by 90 degrees. So for me, that's enough. Great, so that's our first PCell created with a macro in KLayout for the spiral. There will be more of these videos about different macros that we can implement, and if you have questions, please leave them in the comments.